Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the molar entropy of a constant volume sample of argon at 250 Kelvin. Given that it is 154.84 at 298 Kelvin, the molar constant volume heat capacity of argon is 3 over 2R. So this information is easy, even though like the question sounds like a mouthful. The first thing you have to do is, of course, write out your parameters. We're told to calculate the molar entropy of a constant volume sample of argon at 250 Kelvin. So really what we're looking for is this. So we're looking for the molar entropy, which is SM, or you can just say S, of a constant volume sample of argon at 250 Kelvin. So this is what we're looking for. Given that it is, meaning the molar entropy is 154.84 joule per mole Kelvin at 298 Kelvin. So the molar entropy at 298 Kelvin would be 154.84 joule per mole Kelvin. The constant the molar constant volume heat capacity of argon is 3 over 2R. So that would be CV, comma M, because it's a constant volume process. That's just going to be 3 over 2R, which is the same thing as CV, comma M, equals to 3 over 2 times 8.3145 joule per mole Kelvin. So that's basically how it's done. 3 over 2 times 8.3145 is the same thing as 12.4718 joule per mole Kelvin. So now we have like this parameters written down. Now I wanted to explain something to you guys. The formula to solve a question like this, the general formula is the molar entropy at the final temperature is equal to the molar entropy at the initial temperature plus the heat capacity CVM ln T final divided by T initial, where CV comma M is because it's a constant volume process. It is if it's a situation where you're dealing with a constant pressure process, you're gonna have CP comma M. So just put that in mind that you can have this question and you're actually gonna be dealing with a CP comma M because of that will be a constant pressure problem. But here we have a CV comma M. So just know that like the formula can be used either way. Now I want to quickly mention something to you. We already have we already have um this one here. We already have this here. We have this. We have CV comma M. But we have to determine what is the initial temperature and what is the final temperature. You can see in this question that we're told to calculate the molar entropy of a constant volume sample of argon at 250 kelvins, given that it is 154.84 at 298 Kelvin. What this is telling you is that given that it is this, because of how the grammar is worded, we know that the initial temperature is going to be 298 Kelvin. Then there's going to be a decrease in temperature to 250 Kelvin because when they said given that it is 154.84 at 298 Kelvin, that is indirectly telling us that T initial is actually 298 Kelvin. So we can write that here. T initial is going to be 298 Kelvin. And then the temperature that we're actually giving later on is going to be the final temperature, which is 250 Kelvin. And calculate, we're supposed to calculate the answer for that. So anyways, that's just basically how it's done. So we're now basically going to substitute, right? So the molar entropy at the final temperature, that's going to be 250 Kelvin. So that's what we're looking for, is equal to the molar entropy for the initial temperature, that's 298 Kelvin, okay, plus, well, first of all, doing the first substitution, plus CV comma M, so that's just going to be 12.4718, okay, joule per mole Kelvin, times ln T final, okay, divided by T initial. So T final, that's simply 250 divided by 298. So 250 kelvins divided by 298 kelvins. So that's basically how it's done. We can, of course, rewrite this by substituting the molar entropy at 298 Kelvin. We're going to rewrite this formula. So SM of 250 that we're looking for, Kelvin, is equal to the molar entropy at 298 Kelvin. We have that to be 154.84 joule per mole Kelvin. So 154.84 joule per mole Kelvin plus 12.4718 joule per mole Kelvin times ln 250. Let's do it here. 250 Kelvin divided by 298 Kelvin. We cancel out the Kelvins. 250 divided by 298 is the same thing as 0.83893. So that's basically how it's done. So of course we have SM for 250 Kelvin, okay, is equal to 154.84 joule per mole Kelvin plus, now we're going to just work with this information here, plus 12.4718 joule per mole Kelvin times ln 0.83893 is just simply negative 2.1904 joules mole, sorry, negative 2.1904 joule per mole Kelvin. So that's it. So 154.84 joule per mole Kelvin minus 2.1904 joule per mole Kelvin is just simply going to give you 152.6496 joule per mole Kelvin. Now, if we go back to our question, we see that the molar entropy for the initial temperature was given to us in two decimal places. So we're going to put that into account and we're going to put our answer, our final answer, in two decimal places. So what our molar entropy or at 250 Kelvin is actually going to be 152.65 joule per mole Kelvin. And it's also possible that you'll be asked, this is in two decimal places. It's also possible that you'll be asked to put this answer in three sig figs. That's how it usually is in chemistry, or just because we have 250 kelvins here, we have 298 Kelvin here, that's three sig figs. You can also write this in three sig figs. And in three sig figs, molar entropy at 250 Kelvin is actually going to be 153 joule per mole Kelvin. So it can be either of the two. So if you have any questions, make sure you put in the comment section. If you have any concerns or suggestions, also put in the comment section. Please make sure you give this video a like and make sure you subscribe if this has been very, very beneficial for you. I'm very excited that I was able to teach you today. I also wanted to mention that if you're a student who is struggling with any of your STEM related courses, whether you're in middle school, high school, or college, I'm a tutor that helps students succeed in their academic career. I also help mentor students throughout your academic life. So if you have any questions, make sure you email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.